So let me show you another unusual question for the P3 integration that came during October number 11 paper 3 variant 3, and the entire question usually is a part of a doubt for the students, specifically the second part. So the first question is going with respect to integration using substitution, and we have to prove that this integration is equal to that. Now a lot of students are able to do it comfortably, but still I have seen some of the students struggling a bit over here. So I'll do the first part as well and then move on to the second part. So I know that u is equal to 10x. So I'll differentiate my du with respect to x. It will become sec square x. I know that there is a relationship of 1 plus tan square is equal to sec square. So I'm going to utilize it over here and say that this is same as writing 1 plus u square, because 1 plus tan square is same as writing 1 plus u square, because u is equal to 10x. And I'll now convert my limits from x to u. When x is equal to 0, my u will be tan of 0, which is 0. When my x is equal to pi by 4, my u will be equal to tan of pi by 4, which is equal to 1. So my limits go from 0 to 1. Now along with this, I'll just convert this in the form of u and try to integrate it from here. So integration from 0 to pi by 4 of tan of n plus 2x plus tan of nx dx will be same as going from integration 0 to 1, then u to the power of n plus 2 plus u to the power of n times, in place of dx, if I make dx the subject over here, it will become du over 1 plus u square. Du over 1 plus u square. Now how can I integrate this further? Clearly, you should be able to notice that u to the power of n, you can take it as a common factor, but a lot of students struggle over here itself that how can I proceed ahead after this? So yes, the idea is you're going to say that this is integration of, I'll take u to the power of n as a common, and then I'll be left with u square. So it is going to become u to the power of 2 plus n, and then this is 1. Now this is divided by u square plus 1 because of this, and du. The integration goes from 0 to 1. Clearly this and this cancels out, and you have to integrate this, which will be coming out as u to the power of n plus 1 over n plus 1. Now apply the limits of 0 to 1. If I put limit of 1, it will become 1 to the power of anything is 1. So it will become 1 over n plus 1 minus 0. Of course, it will become 0. And that is how we have proven that the integration from 0 to pi by 4 of tan of n plus 2x plus tan of x to the power of n dx is equal to 1 plus 1 over n plus 1, as we wanted to prove. Now let's move on to the actually challenging part, that is question 2 part B. But before solving part B, let's see how to solve part A. This is going to give us some kind of an idea or a hint for part B as well. Part A is also pretty easy. It's not at all difficult. So for that, I'll just create some kind of space over here for me. Let me quickly delete everything. And let's come over here. I know that because I have used the word hence over here in the question, I can utilize the answer from the previous part. And I know that if I am having 10 to the power of n, then just a term with a power of 2 more than the n, then I know its integration will be 1 over n plus 1 if the limits are 0 to pi by 4. So I'm going to try to implement this over here. I can convert the sec power of 4x and the sec power of 2x with respect to 10x terms. So in part A, we are having integration from 0 to pi by 4 of sec power of 4x and sec square x. I can take sec square x as a common, so that it becomes sec square x times sec square x minus 1 dx. If you multiply this, you get sec power of 4x. If you multiply this, you get sec square x. Now I know that 1 plus tan square is equal to sec square. So tan square is simply equal to sec square minus 1. So this is my tan square x. I know that. And what about this sec square x? I can write this as 1 plus tan square x. So this is same as writing integration of 1 plus tan square x multiplied by tan square x dx. Of course, don't forget the limit 0 to pi by 4. And if I continue integrating this will be same as writing 0 to pi by 4. And then I have to integrate 10 square and 10 to the power of 4. So now it is in the format as we wanted, that the power is having a difference of 2. And there is an addition between them. Now the value of n over here is clearly 2. 2 plus 2 is 4. So yeah, n is equal to 2. So the answer will become 1 over 2 plus 1, which is 1 over 3. So my answer over here comes out as 1 over 3. Now let's look into how we can approach part B of this question, where a lot of students struggle. So everything is already in terms of 10x. But the problem over here is, are the powers having a gap of 2? 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 is 9. That is also matching. But then what is the thing which is not matching with the equation given over here? It's the coefficients. The coefficients over here and over here are equal. But over here, clearly we can see that the coefficients are not equal. This is a 10 cube x. Here is 5 10 to the power of 5x. But if it was, let's say, 10 to the power of 5 plus 10 to the power of 3, I know that the value of n was equal to 3. But then because you are having 5 10 to the power of 5x, it's a bit complicated. So just use algebraic manipulation. You can break 5 10 to the power of 5x in this format. 4 times 10 to the power of 5 plus 10 to the power of 5, which is 5 times 10 power of 5 plus 10 power of 3. So now this, for this part, if I integrate, n will be equal to 3. Similarly, I can do the same thing over here. 10 to the power of 9 plus 10 to the power of 7 plus 4 to the power of 7. 4 times 10 to the power of 7. So this is 4 times 10 to the power of 5. This is 4 times 10 to the power of 7. So I can take 4 as a common factor so that I can get 10 to the power of 7 plus 10 to the power of 5. Over here, n is equal to 5. And similarly over here, n is equal to 7. So the problem is sorted now. The main confusion with this question for the student was that if the coefficients are not same, how they can solve it. But if you are a thinker, not someone who will stop by looking at the question, the idea should pop up that I can try to create the same coefficients. And in that process, you will see that, yeah, I'm able to get the answer. So to integrate this, I just use t instead of writing the whole 10. This is same as writing t to the power of 9 plus t to the power of 7 plus 4 times t to the power of 7 plus 4 times t to the power of 5 plus t to the power of 5 plus t to the power of 3. And of course, it is 10x, 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 not t. So actual variable is x, not the t. Just to save our time, I am writing t over here. And now I can say that this integration will be 1 over 7 plus 1, which is 8. Then 4 times 1 over 5 plus 1, which is 6. Of course, I'm using this rule if you're getting confused. Okay. And then for the last one, this is 1 over n plus 1. So n value is 3 in this case. So it will become 4. You can substitute all of this into your calc and get your answer. So you are having 1 over 8 plus 1 over 4 plus 6, 4 over 6. And the answer comes out as 25 over 24. So that is how you do this kind of unusual questions. It is all about manipulations. If you are good with the manipulations, everything is easy in P3.